I gave you this problem at the end of the last video, and I've started it here. I know that if 3 is a 0, that's going to mean that x minus 3 is a factor. So I can write this as f of x equals x minus 3 times some other factor, and I want to try to find that. To find that, I'm going to take f of x and divide it by x minus 3. And so that's what I've done here using synthetic division. Now, I'll let you double check that you got things correct here. We should have gotten a remainder of 0. And this, in code, is that second factor. This is my constant, my x's, my x squareds. So we'll have 2x squared plus 2x minus 5 is our second factor. Now, the last time we did this, we got a quadratic here that we were able to factor pretty easily. Okay. This one, try as hard as you want, it doesn't factor nicely. Okay. But that doesn't mean it doesn't factor at all. It's just not going to factor with nice integer factors. We're going to have some messier numbers. I know that zeros correspond to factors. Sometimes zeros are also called roots of a polynomial. Our book calls them zeros, so I'll try and use that vocabulary, but roots and zeros mean the same thing. All right, so if I can find the zeros of this, well, that's going to help me finish up part A, and that'll also help me finish up part B, because zeros will correspond to factors. But I have a nice way of finding the zeros of a quadratic. If I'm saying 2x squared plus 2x minus 5 equals 0, and I'm not getting it by factoring, I can get it using the quadratic formula. So I'll record my A, my B, and my C, 2, 2, and negative 5. I know that x is going to be the opposite of b, plus or minus root b squared minus 4ac all over 2a. Substituting in, the opposite of b will be negative 2, plus or minus the square root of 2 squared is 4, minus 4 times 2 times negative 5, all over 2 times 2 is 4. Now, that becomes negative 2 plus or minus the square root. These two negatives will cancel, so that's going to become 4 plus 8 times 5 is 40, so that's 44 all over 4. Now, I do need to simplify that. That root 44, I can say this is negative 2 plus or minus root 4 times root 11. 4 is a perfect square that goes into 44 all over 4. So that's 2 plus or minus 2 root 11 over 4. Now I can't cancel the 4 with just that 2 or just that 2, but since there's a 2 in both places, I can factor it out and get 1 plus or minus root 11 times 2 all over 4. Now with that 2 connected to the rest of the top by multiplication, I can cancel. And so we get 1 plus or minus root 11 all over 2. Now, those are the two zeros of this. We were given that 3 is a 0. So for part A, finding all of the zeros of f, I can now say that's going to be 3, the one that I was given, and then 1 plus or minus root 11 over 2. That's a total of 3 different zeros, and it's totally fine to write these two just using a plus and minus. If you prefer to write them separately, that's fine. Now for factoring, here I'm going to again go from the 0 to the corresponding factor. Just like when we said if 3 is a 0, x minus 3 is a factor, now I can say negative 1 plus root 11 over 2 is a 0, so x minus 1 plus root 11 over 2 must be a factor. And x minus 1 minus root 11 over 2 must be a factor. So for each of these two zeros, one with the plus sign, one with the minus, x minus that 0 is going to be a factor. Okay. So these are factors that I probably wouldn't get by factoring, because usually we're factoring over the integers. We're just listing integers that would multiply to give us what we want, not listing these irrational numbers that contain roots of 11. Okay. But I know that these guys are factors. Now I do need to be very careful when I'm using the quadratic formula like this, because I know I'm supposed to be multiplying this out to get back to f. The lead term of f is 2x cubed. I've written this right now as a product of three linear factors, each of which has a lead term of just x. So if I multiplied out, the lead term of this would just be x cubed. Now I know I can't have any more factors with x in them, because then I bump up to a fourth degree polynomial, but I can have a factor of 2. So be very careful, because if you know that you have a 0, you know that x minus that 0 is going to be a factor. That is true. But it's not necessarily the case that if you have three zeros, x minus the first 0 times x minus the second 0 times x minus the third 0, that might not cover all of your factors. You could have an additional constant factor. You need to just double check that you're going to get the correct lead term. Now we do, so this is completely factored. Okay. Now, if you preferred to multiply out that 2 and combine it with one of the other factors, you could. So you could say this is x minus 3 times x minus 1 plus root 11 over 2 times, here, I could, if I wanted to, distribute the 2. So I could say it's times x minus, 2x minus, now when I distribute to this fraction, I'll cancel the 2. Do be careful then, I've got to distribute that negative, minus 1 plus root 11. So it's totally fine to combine a constant factor with a factor that has some x's in it. Either this or this would count as fully factored. I'd probably stop here. I think that's actually simpler than going ahead and multiplying it out. But just wanted to point out that that's a viable option.